Hello Algebra 2 students, here's a video of example 6 for section 1.2, writing an equation from a graph. So we have a word problem here. Let's listen to their description.
A scenic train ride makes trips on an old mining line. The graph shows the distance y in kilometers of the train from the station x minutes after the ride begins. What equation represents the distance from the station as a function of time? What is its domain?
So two questions. We're going to have to come up with the equation for this. Hopefully you can realize which parent function it is. Is it the y equals x squared? Is it a linear function? Is it an absolute value equation? And then in the end we have to figure out the domain. Actually the domain you could probably figure out right now. The graph shows a reflection of absolute value graph across the x-axis. Whenever you have that, you want to memorize this part right here. All right, the y equals negative a, absolute value of x minus h plus k, because what's that? That can be your generic function, and all you have to do is notice that the vertex here is at 15, 15, and that's your hk. So you can plug in here. For h, you can plug in 15, and for k, you can plug in 15. Okay? Then you only have to figure out what the negative a means. And it's a negative a because it opened down. And this is how you figure out what a is. You can substitute any point that you want into the equation. Oh, we already did that. Here we go. You can substitute any of these points into the equation, except for the 15, 15. It goes through 0, 0. So that's the easiest one. If you plug in 0 and 0 in for x and y, you're going to get this equation. 0 equals negative a, absolute value of 0 minus 15 plus 15. And solving that for a, we get 1 in this case. So that means 1 is going to be right here for a, and you're going to have your final equation. Y equals negative 1, but you don't have to write the 1. Negative absolute value of x minus 15 plus 15. That's the equation for this red graph right here. And the other question was, what's its domain? The domain is from 0 to 30 inclusive, and to write that in interval notation would look like this right here. 0 to 30 inclusive. Okay, that's the only one that they gave us to do, that they helped us with. Now they want us to change it a little bit. Start off with the same graph, but this time they say, how would the graph and equation be affected if the train traveled twice as far in the same amount of time? So you're going to think about how that would change the graph, and then how it changes the equation. Click pause, give it a shot, and then come back when you're ready. Let's see, we have, if it goes twice as, I think I have this set up right here. If it goes twice as far, instead of being 15 miles away, it's going to be 30. Let me estimate. This is like 24, 28, so maybe 30 would be up here. So it's going to go that high in the same amount of time, it said. So what we're trying to do is come up with here's the graph of it. The other part was, what's the equation? All right, now do you remember the generic form of an equation? Y equals, see if I have enough room, negative a, absolute value, x minus h, and plus k. And in this case, this went twice as high, and it's at 15. So 15, 15, comma 30. So that's going to be h, and that's going to be k. So y equals negative a, absolute value of x minus h, but h this time was 15. I guess it's the same as it was before, plus 30. Now, how can we figure out what a is? We can plug in 0, 0. Plug in 0, we have 0 equals negative a. Absolute value, to save space if you don't mind, plug in 0. 0 minus 15 is negative 15. Plus 30. I'm running out of space here, but 0 equals negative a times this was negative 15. So the absolute value of negative 15 is positive 15. So right now I have negative 15. No, yes, I have the negative here, and that's positive 15 plus 30. Right? This is positive 15, but then it's a negative times a, so negative 15a. If I keep going this, I don't know if I'm going to run out of space or not. It's going to end up with a equals negative 2. I would subtract 30 from both sides, and I get this. And then I'm going to divide by negative 15. Oh, it's going to be positive 2. I apologize. Final equation, because a equals positive 2, is I plug in 2 in there, and 15 in there, and 30 in there, to get y equals negative 2, y equals negative 2, absolute value of x minus 15, plus 30. The key is, again, this equation right here, knowing how to find the values of a, h, and k. Now you should be able to do problems 33, 34, 35, and 38. That's it for this video. Have a great day.